Hello everyone. So this is the second part of chapter 25 where I'm going to show you how to do integration by substitution. Previously, in the previous video, we talked about basic integration, what it means, which we said just implies just reversing what we did when we took derivatives. So here I'm going to show you a very useful and important technique to do integration, which is integration by substitution. And I'm going to begin with this little integrand here. So this says to take the antiderivative of x squared plus 1 cubed multiplied by 2x dx. Now if you would observe, you would see that what you have in the 2x dx is the derivative of x squared plus 1 without the cube, that is. So when you do integration by substitution, what you have to do is you have to find an appropriate substitution in there, right? Whose derivative will be replaced into the integrand so that it will make it a bit easier to deal with, right? Because in this situation we have here right now, if we let u be x squared plus 1, we can take the derivative of u as a function of x, which will be du dx. That means that du is 2x times dx. So the integrand we have, which was a function of x, which was a relationship in terms of x previously, has now become a relationship in terms of u, because now we can replace x squared plus 1 with u, and we would have u cubed, and then we would have 2x dx, which is what we have now. That would be du. So the relationship is now a function of u. And this is just a power relationship, which we saw previously. You can take the antiderivative of power relationships, and that would just be, you just add 1 to the exponent and divide by the new exponent, right? That will be u to the power 4 divided by 4 plus the constant of integration, c. But there was no u in the original relationship. We introduced u in there, so we have to substitute it back in. That means our integrand will be x squared plus 1 to the power 4 divided by 4 plus constant of integration, c. Let's do another example. We want to integrate x squared times square root of x squared plus x cubed plus 2 dx. Like we did in the previous example, if you're going to integrate, one of the things you may want to think about is what appropriate substitution can you make in here, right? But first of all, we should note that the square root we have in here is a power, right, to the power half, which I've written in here. And then if you notice, you will see that x cubed plus 2, if you take the derivative of it, the derivative is 3x squared, right? So, and you can see x squared in here already. So perhaps we're going to let u be x cubed plus 2, and then we'll see where that leads us. So if we let u be x cubed plus 2, we can take the derivative of u, that will be 3x squared plus 0, that's just 3x squared. And so du is 3x squared dx. But you see what you have in there is x squared dx, not 3x squared dx. So what we have to do is we are going to manipulate this a little bit. We are going to divide both sides of this by 3. We're going to divide both sides here by 3. Okay, so that would give us du over 3, which will equal x squared dx. That's exactly what we have in there right now. So now we can make that substitution. Once we rewrite, we have x cubed plus 2 to the power half times x squared dx, right? So which is your du over 3, right? This one that you have in here is du over 3. Okay, so if we do that, we would have the integral will become integrating u to the power half times du over 3, which will lead us to 1/3 times the integral of u cubed to the power 1/2 du. That's just a power relationship like we've seen before. So if you take antiderivative of that, we'll just add 1 to the exponent. So 1/2 plus 1 is 3/2, and we divide by 3/2 plus constant of integration c, which will give us a result of 2 over 9 times x cubed plus 2 to the power 3/2 plus constant of integration c. So now it's time for you to try one. Okay, so what I'd like you to do is I'd like you to pause the video now and try to take the antiderivative that we have here And once you are done, you can continue the video to see what I have done. Okay, so please pause the video now. But a good hint for you would be to let u be 1 minus 2x squared. So pause the video now. Okay, so what did you do? So this is what I did. So like I suggested to you, I am going to let u be 1 minus 2x squared. So du dx will be minus 4x, and du will be negative 4x dx. But you can see what you have in there is 8x dx, right? So you would have to adjust this a little bit. If I multiply both sides by negative 2, I would have exactly 8x dx. So negative 2 du is 8x dx. So I will replace 8x dx with negative 2 du in the integral that I have. So I will have a relationship written in this way, and so I have the integral u to the power half times negative 2 du, which I can now take integral of. It's an integral of a power. It will be u to the power 3 halves divided by 3 halves plus c, and the final result will be negative 4/3 times 1 minus 2x squared to the power 3 halves plus c. So I hope you got that one correct. The next thing I want to do for the remaining few minutes is I want to show you how to find the constant of integration. So previously, all the integral that we've done, you will see that we always have this constant of integration c in there. So I'm going to show you a couple of examples where you actually find what this constant is. What you need is that you need to have a little more information about the integral that you are trying to do, as illustrated in the following examples. So number one, excuse me, find y in terms of x, given that the y dx is equal to 3x minus 1, and the curve passes through a point 1, 4. So the y dx here is the derivative of the curve of the function that we're talking about. So what we want to do is we want to find a general expression for this curve, right? Which means that we have to take the integral of that curve. Okay, integral of 3x minus 1 dx, which if we do, we'll get 3x squared over 2 minus x plus c. So now we want to find out what c is. That's easy to do now, since we know a point on the curve, this point. The point is 1, 4. That means when x is 1, y is 4 on this curve. If we put that in our result here, after we took the integral, we'll be able to solve for c. So if we do that, it will look like this. So 4 is equal to 3 times 1 squared divided by 2 minus 1 plus c, which if you rearrange and solve, you will get that c is equal to 7 over 2. So if we replace that in our integral that we did, our result here will be y equals to 3 half x squared minus x plus 7 over 2. You try one. Find y in terms of x if the y dx equals to 8x plus 1 and the curve passes through negative 1, 4. So again, like we did previously, pause the video now and try it, and then when you finish, you can continue to see what I have done. So pause the video now. All right. So what did you do? We are taking the integral of 8x plus 1. That's going to be our y, is our curve. So if we do that, the result will be 8x squared over 2 plus x plus c, which if you simplify, you will get 4x squared plus x plus c. But we have a point on the curve, negative 1, 4, which if we substitute in there for y and x, you will get 4 equals 4 times negative 1 squared plus negative 1 plus c, which will give you c to be minus 1. So if we substitute but that now in our function, in our curve that we obtained by integration, you will get y equals to 4x squared plus x minus 1. I hope you got that right, and I hope that's clear. So I have some practice questions that I've chosen out for you from your textbook, section 25.2. I've picked out a few there in there. Please walk your way through these examples and make sure that you have a good grasp of what's going on there. I am going to be putting up more lessons dealing with the other sections for chapter 25.